Learners, I welcome you to Eko Learners Support. Today's class is going to be very interesting. I am your chemistry instructor, Juma Rashid. Come on, let's look at what we have today.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Today, we will be discussing a fundamental topic in chemistry, and that is the particulate nature of matter. Under that topic, we'll look at the structure of an atom, isotopes, and the Dalton's atomic theory. I want you to write this topic in your notes as well as the dates, and let's get started. Let's look at the learning objectives. At the end of this class, you should be able to name the 3 building blocks of matter. 2, you should be able to state the definition of atomic number, mass number, and isotopes. 3, you should be able to calculate the number of protons, neutrons, and electrons in a given particle. And finally, you should be able to state the 4 postulates of the Dalton's atomic theory. I believe that you're ready to go, but let's be inspired by this quote. It says, "Small things, when aggregated, can have a profound impact on the world around us." This simply means that atoms, as small as they are, they can build up to become complex compounds, which we use in our everyday life. Now, what are the building blocks of matter? If you look at the diagram here, it is explicitly stated here that matter can be subdivided into molecules, atoms. Okay, so, and then the third one is ion. So you have atoms, you have molecules, and the last one, ions. Now, what is an atom? An atom is the smallest part of an element. A molecule is the smallest part of a substance. That is the difference between an atom and a molecule. When the word atom is used, the substance referring to must be an element, but a molecule is used for any substance. Ion is an atom that possesses electric charge. So, we've already discussed that an atom is the smallest part of an element. For example, gold is an example of element which is very useful in making currencies and jewelries. As you can see here, this is a block of gold, all right? But just within this block of gold, you have atoms that come together to make up that element. Molecules, like I said, is a smallest part of a substance that normally exists alone. For example, if you have a slice of bread and then you break it into 2, and then the 2 into 2, and you continue dividing it until you have a piece which you can no longer divide. That piece is a molecule. Why? Because the bread is not an element. But if it is an element like sodium, the smallest part of it is an atom. That is the thin line difference between a molecule and an atom. A molecule can also be formed when 2 or more atoms come together. For example, when you have 2 atoms of hydrogen, they can combine to form hydrogen molecule. We've already explained what ions are. They are atoms possessing charge. There are 2 types of ions. You have the cation, which are the positively charged ion, and the anion, that are negatively charged ions. The cations are usually formed as a result of loss of electrons, while the anions are formed by gain of electrons. Let's keep moving. So, atomic number and mass number. Atomic number is one of the numbers that is used to define or to describe an atom, and it is simply the number of protons in an atom. Now, If you look at the structure of an atom, you will see that an atom is a sphere that consists of a nucleus, which is the center. Okay? Now, that nucleus is made up of two particles, the proton and the neutron. And the third particle is the electron, which is revolving around the shell. This is the proton, and this is the neutron. These are what we call subatomic particles. So the atomic number, which is represented as Z, is simply the number of protons in an atom. So for example, if the atomic number of sodium is 11, what we are saying here is that sodium actually contains 11 protons. Now, because an atom must remain electrically neutral, it is a worldwide convention that the number of protons must always be equal to the number of electrons in a neutral atom. So you have to take note of that. The number of protons must be equal to the number of electrons. Okay? Let's keep going there. The other number is called the mass number. The mass number is represented by A, and it is simply the sum of the proton and the neutron. So the mass number is proton plus neutron. So if you need to calculate the number of neutrons in an atom, all you need to do is to say neutron here will be the difference between the mass number and the number of protons, which is the atomic number. For example, if you have, let's use sodium again. So I have sodium represented this way, Na, Na 1123. So here, this is the atomic number, this is the mass number. So I want to find the number of proton, the number of electron, and the number of neutron. The number of proton is simply the atomic number, that is 11. The number of electron is also the same as the number of proton, which is also 11, while the number of neutron is the difference between the mass number, 23, minus the atomic number, and that gives 12. So this is how the subatomic particles in an atom are calculated. Okay, let's keep going. Now, isotopes. Isotopes are atoms of the same element that have the same atomic number but different mass number. Please, it is important for you to know that isotopes are atoms. That is the first thing you must add in your definition. They are atoms of the same element that have the same atomic number but different mass number. For example, you can have different isotopes of hydrogen. You have the normal hydrogen, which is 1,1. You have deuterium, which is hydrogen 2,1. Then you have tritium, which is hydrogen 3,1. So you can see that the atomic numbers are the same, but the mass numbers are different. For example, you can also have oxygen, okay, 816. You can have another one, 818. The atomic numbers are the same, but the mass numbers are different. That's what we mean by isotope. And the phenomenon that gives rise to isotopes is called isotopy. It's called isotopy. So the major difference, if you look at the isotopes here, the major difference between them is in their number of neutrons. In the hydrogen here, the normal hydrogen here, okay, the number of neutrons here is 0 because this is 1 minus 1. But the number of neutrons here is 1, while the number of neutrons here is 2. And that is why isotopes usually have different physical properties, but similar chemical properties. Okay? This is an illustration of how you can derive the relative atomic mass from the relative abundance of isotopes. And you can see here, we have two isotopes of chlorine 1735 and 1737. What is done to get the relative atomic mass, what we call RAM, here is simply that this is the relative abundance of these isotopes. That's 75 divided by 100. Then you multiply it by the mass number by 35. That gives you this value. Then you sum it up with this other one. This is 25 divided by 100 multiplied by 37. And that gives us 35.5. You can be asked in the exam to explain why the relative atomic mass of elements are not usually whole number. The reason is because they are usually calculated from their isotopes. So we have an exercise here. We're asked to complete this table. All right? Particle, number of protons, number of electrons, number of neutrons. So let's quickly, I'm giving you just a minute, okay, to complete that table. By the time we come back, I want to see how you fare. So you're welcome back. So let's see how you fare in this particular task. All right. Now, the table is completed here for you, and I hope that you got many of these correctly. All right. For the hydrogen, the number of electron is 1 because the number of proton is also 1. While the number of neutron is 0 because 1 minus 1 gives is 0. Aluminium ion. This is aluminium 3 ion. What this means is that the aluminium has lost 3 electrons, and that's why it has that plus 3 charge. So the number of protons still remains the same, that's 13, but the number of electrons is now 3 less, and that's why it is 10 there. The number of neutrons is simply the difference between the mass number and the atomic number, and that gives 14. Another one is the oxide ion, where the oxygen has gained 2 more electrons. So the number of protons remain 8, but the number of electrons is now 10 because 2 more electrons have been added, while the number of neutrons is different between 16 and 8, and that gives 8. The other answer is on the board, okay? Why isotopes have different mass number? It is because they have different number of neutrons, but the same atomic number. And you can simply use that formula to calculate the relative atomic mass of this particular atom here. So what was done is that the first percentage is 68, that's 68 divided by 100, multiply it by what? The mass number there, and then is added to the other abundance, which is 32 divided by 100, multiplied by 65. The answer gives 1.0. In relative atomic mass, you do not add the unit. I hope that you are able to do well in this particular exercise. So the question is, who is Dalton? Okay, and this is the profile of that great man. He was born on in 1766, okay, and is an English chemist, a meteorologist, and a physicist. You can imagine having so much responsibility. He's best known for his pioneering work in development of modern atomic theory and his research into color blindness, which is sometimes referred to as Daltonism. So Dalton was able to put together some theory which up to today still remains the basis of many theories that exist today. The first one is that all elements are made up of small indivisible particles called atoms. 2, atoms can neither be created nor destroyed. That's a familiar theory, okay? 3, according to Dalton, atoms of the same element are alike in every aspect and they differ from atoms of other elements. 4, when atoms combine, they do so in simple ratio, either ratio 1:1, ratio 1:2. For example, in water, the ratio of hydrogen to oxygen is ratio 2:1. And lastly, all chemical changes result from the combination or the separation of atoms. I would like you to quickly write down these 5 great postulates of Dalton's. Some of these postulates have been modified, and that's why today we have the modification to them. Let's look at the modification. An atom is no longer the smallest part of an element because we now know that even an atom contains subparticles, which are the proton, the neutrons, and electrons. Don't forget that chemistry is an emerging field. It is developing every day, and as new knowledge emerges, modifications are done to existing theories and laws. The second modification that is done is that atoms can now be created. Yes, we can create atoms now, and atoms can be destroyed. In areas of nuclear chemistry, an atom of uranium can actually be destroyed when it is used as atomic bomb. And we create new atoms on a daily basis now. So when radioactive atom disintegrates, they emit particles and new things are actually produced. 3, the atoms of the same element are alike, but they differ from atoms of other elements. This was before the phenomenon of isotopy was discovered. But since isotopy has been discovered, that particular theory has been modified. And lastly, in large molecules such as protein, starch, we do not have atoms combining in simple ratio. You can have thousands of carbon atoms linking together to form giant molecules. So these are the modifications that have been done to Dalton's theory. So, know your heroes. Who discovered proton? Do you know? Yes, it is Ernest Rutherford. Rutherford is the one that discovered proton. Next, who discovered neutrons? Do you have an idea? Let's find out. Neutron was discovered by James Chadwick. These are very important knowledge that you need to have. You may be representing your school in quizzes. Next, who discovered electron? And it is J.J. Thomson. So these are your heroes, and I hope that you are aspiring to also be like them. Let's look at our top exam-styled question very quickly. The first one says the atomic number of an element is precisely what? The number of protons in the atom, the number of electrons in the atom, the number of neutrons in the atom, or all of the above. Which of these options do you think is correct? The atomic number is actually the number of protons in an atom. So the correct answer is option A. Well done to you. Let's move on. The second one says we should consider the element represented by X. Okay, what does this number written down, what does it mean? You are correct. That is the atomic number. And how about the one that is written up of the symbol? Very good. That is the mass number. Okay, so the question is, we should state the relationship between these two atoms. If you look at these two atoms very well, you can see that they have something in common, which is that they have the same atomic number. So the relationship we are looking for here is isotopy. Don't say isotope. The relationship between these two atoms is isotopy. And what is the difference between them? The difference between them is in their number of neutrons. They have different number of neutrons. The number of neutrons are different. Very good. So let's move on. This is filling the blanks. A, the quantity of matter in a body is called what? What do you call the body quantity of matter in a body? That is referred to as the mass. Fantastic. You're doing great. Change of liquid into vapor upon heating is referred to as what? What do you think? Very good. The answer is vaporization. Vaporization. How about changes of solid directly into gas? What name is given to that? For example, you have camphor and then it begins to sublime. What name is given to that? Very good. That is called sublimation. Sublimation. And lastly, the state of matter where the molecules can be compressed. Is it a liquid? Is that a solid or is it a gas? Fantastic job. That describes gas. Gas are compressible, and that's why you can compress your gas into your cylinder, which you use for cooking at home. I thank you very much for staying tuned to the end, and I hope that you are feeling confident now to be able to go into your exams and perform optimally. Don't forget that in today's lesson, we started by looking at the subatomic particles, which are atoms, molecules, and ions. We went further to look at what is isotopy, and we looked at examples of isotopes. We also looked at how the relative atomic mass of an element can be calculated from the relative abundance of the isotopes. And we ended by looking at the Dalton's theory, okay, and the modification that have been done to that theory.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Until next time when I see you in class, make sure that you use the link on the screen to give your feedback, your suggestion. I'll be willing to read them all. Bye for now.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.